Graphing quadratic inequalities in two variables. So this is going to be almost exactly the same as graphing a line, but instead of a line, it's going to be a parabola. So remember that standard form is y equals a x minus p squared plus q, and p and q are the vertex. So graphing the inequality y is less than 3x squared minus 4. First, we've determined what the vertex is. Because x isn't moving left to right, it's 0, and our q is 4, negative 4, so it's 0 and negative 4. It's going to open up, and it's going to have a broken line because it's a less than sign, and it's going to have a vertical stretch of 3. When we graph parabolas in this unit, it is really important to be very careful with our graphing, so it's going to be a little bit more precise. So the quickest way to do it is to make a little table of values. Now we know that the graph of 3x squared minus 4 will be congruent to 3x squared. It'll be the same thing except moved 4 units down. So we're going to graph as if it was 3x squared. So if x was 1, y would be 1 squared, which is 1, times 3, which is 3. If it was 2, it'd be 2 squared, which is 4, times 3, which is 12. And usually you only have to do the first 2 steps. So we're going to graph this. So if we graph our vertex at 0 and negative 4, now from here we go over 1 step for our x, and then up 3. So 1, 2, 3, and there's our first point. It works the same way to the left. So this is like taking steps. It's a step pattern. Now this one, we go over 2 and up 12. So over 2 from the vertex, and up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It should fit on your paper. So that would be the same on the other side. Once we have our parts, we connect our lines, and we remember that this is a dotted line, so make sure you do dots. Well, I guess it doesn't really work on here. Usually I just draw the line and an erase for the dots, but apparently not on the iPad. So there's our parabola. Now we're going to test our origin to see if it is included. So 0 is less than 3 times 0 minus 4. So 0 is less than negative 4. This is not true, so it does not satisfy, so we shade the outsides. For the following word problem, it's going to have 2 numbers, so let's let x equal one number and y equal the other one. So when we read this equation, we want to write as we go. So the sum of 2, so 2 plus something, and 3 times the square of one number, so x times this, x is our one number, is greater than or equal to 5 minus twice the other number. So there's our inequality. We want to put it into standard form, so we're going to add 2y to the other side and move 3x squared to the other side, and minus 2. So we have negative 3x squared plus 3. And then we're going to divide by 2. So y is greater than or equal to negative 1.5 x squared plus 1.5. Our vertex is 0 and 1.5. It opens down. It has a solid line. and it's going to be stretched by 1.5 negative. So if we make our table of values, x and y, this is for negative 1.5 x squared. If we go over 1, we're going to go down 1.5. We go over 2, it'll be 2 squared, which is 4 times negative 1.5, which is negative 6. So if we graph this, our vertex is at 0 and 1.5, right about here. When we go over 1, we're going to go down 1.5 on both sides. When we go over 2, we're going to go down 6. So 1, 2, 3, 4, 5, 6 on both sides. And then we connect our dots, and here's our parabola. Now we're going to test our origin. So 2 plus 3 times 0 is greater than or equal to, let's try this again with my room. 2 plus 3 times 0 is greater than or equal to 5 minus 2 times 0. 2 is not greater than or equal to 5, so we shade our outsides. Now it says to choose 2 points that satisfy the equation, so you can literally choose any 2 points that have integer solutions outside in the shaded area. You could choose 1 and 1, you could choose 2 and 2, you could choose 100,000 and 5. It doesn't matter as long as it's outside of this region. And the way to check would be to plug it into your equation. So 2 plus 3 times 1 squared is greater than or equal to 5 minus 2 times 1. 3 plus 1 is 5, which is greater than or equal to 3. This works. If you don't have to show your work when you test it, but if you do want to test, it's a good idea to just type it into your calculator quick to make sure that you got the right answer.